Hello everyone. In this tutorial, I'm going to discuss how to have this kind of graphical user interface. As you can see now, here what you can write a digit, get the print. Okay. Likewise, here what we are we have two main parts here. Basically, the first part is to build up this graphical user interface using Python. So for this application, we are using Tkinter. Tkinter is the standard graphical user interface building library given for Python. So it's a inbuilt library where it's installed already with the Python installation. And the second part is we have to integrate and trained neural network model into this and somehow get the prediction. So we have input the image to the neural network, and we can then get the using the softmax last layer, output layer, softmax layer, we can get the prediction whether it's a digit 0, 1, 2 or up to 9, right? That's what we are mainly trying to do here. Okay, so let me first go through the Tkinter module, right? So here you can see, as you can see now, we have I have given some Tkinter examples. So I'm not going to cover the Tkinter from very basics. So you can go through these examples. I will provide you this link as well. So this explains how to build up simple graphical user interfaces from scratch, right? So please go through these codes as well. So I have included a small note as well. So in this one, this explains how to build up graphical user interfaces using Tkinter. The main steps. So I will explain this as well. So Tkinter is as I mentioned, the standard graphical user interface for Python. We have some other as well, but this is the standard version for Python. And creating graphical user interfaces in Tkinter is quite easy, where we have first encode the Tkinter module, then we have to create a main window, right? A main window, and then we have to apply widgets to the that main window. So what do you mean by that is yes, so I will explain this thing. Now here you can see this is the main window, and we have several widgets here. So widgets are this one, the buttons, labels, right? So those are called the widgets. So that's the main step. Create a main window, and we have add one by one widgets one by one. Then what we have to do, we have write the functionality of each widget. That means, okay, what's going to happen when we are going to press the save, what's going to happen when we are going to press the predict, what's going to happen this way, then when the predict is pressed, how to update this label එක කොහොමද පෙන්වන්නේ මොකද්ද digit එක. So likewise the functionality. So writing the functionality is the third one. So get the main window, Tkinter main window, and add widgets. Finally write the functionality for each and every widget, right? So that's the main steps included in creating a graphical user interface in Tkinter, right? Okay, so Tkinter widgets these are the Tkinter widgets. So we have 15 main type of Tkinter widgets. We have buttons, canvases, text box, entries, labels, menu buttons, and radio buttons. The scales like the sliders, spin boxes, right? So we have several of them, right? So we can, using those things, you can do whatever things. Now I will explain you I will show you Tkinter widgets, right? So what are the Tkinter widgets, right? So you can see now this is a check button, right? And this is check buttons, and this is this is entries, right? And these are buttons, right? And I will show you the radio button as well, right? So these are the radio buttons, right? So likewise, these are the widgets available in Tkinter, right? So I have listed them down here as well. Then we have several other things to discuss. You can go through these slides as well, and these are the colors available in Tkinter. I will use them, and Yes, so we have similar things to discuss. I will discuss it in when I'm going to build up the Tkinter graphical user interface for my application today, right? And other thing, as I mentioned, I will provide you this GitHub link where I have included several examples of Tkinter. So you can, if you are interested, I mean, this is not a mandatory thing to do since our focus is not on graphical user interfaces. We are trying to create neural networks and optimize them. But if you are interested on this thing, you can go through this one. My main target is like show you how to integrate a neural network, a trained neural network with this kind of application, right? So that should be our target. I mean, we are going to train a neural network and we are going to use it a practical application. So that's what our target should be. Now, this is an example for that. So we are using Tkinter. So our main focus is not about Tkinter, but if you are interested on Tkinter, please go through the examples and also slides that I'm going to provide. Okay. So in the last tutorial, Tuesday's tutorial, I trained this MNIST dataset, right? And we use this kind of a neural network, and finally we got the results like we got 99% accuracy, and we inspected the loss and the accuracy, and finally we evaluated the model and got 98% accuracy for test data. Finally, I showed you how to save the weights of the module. Now I told you that this is the knowledge gain by the neural network. This is the knowledge gained by the neural network, and this is saved to a physical file. I mean, no matter how many images you use to train the neural network, right, the weight you are going to get will be like several kilobytes, sometimes several megabytes. I mean, that's depend on how many parameters you have, right? So here for this application we have like 500,000 parameters, right? So we are going to save it. Now this will be saved as this, right? So you can see it is saved here as FFNN MIST.h5. So that h5 is the file format used in Keras to save the neural network model, and that contain like 3.232 megabytes, right? So this is the knowledge gain from like 60,000 training images of handwritten digits, right? So now this means we have saved the knowledge gain from those images, right? And we have it in a physical file. That means we can, this is a portable file where we can, right, take it anywhere you want and use it in our application. Now what we are trying to do now is to use this trained neural network model integrate it with our graphical user interface and get a prediction, right? Before doing that, I will first build up the graphical user interface as I showed at the start of the tutorial. So we will first build that graphical user interface, and later at the last part we will integrate this neural network model with that graphical user interface. Okay, so let me get a new code, right? Let me get a new code, and this will be saved as GUI for handwritten digits. GUI for handwritten digits. Yes, and I'm going to save it, right? So now I'm going to build up the graphical user interface. Yeah. Okay. Right. So first I have to import the Tkinter module. So it will be done for TK. Going to import the Tkinter module. Import TK. Import Tkinter as TK. We are going to import the Tkinter module, and that's it. Then we will try to, now we have the Tkinter module. Now we need to create the main window as I mentioned, and we need to add widgets to that. So I will create the main window like this, window equal tk.tk. So this is how we are going to create the main window. Then we need to run this. In order to run this, you can use win.main loop, this method. So what's going to happen, this is the main window, and now we are going to run the main window. So we are going to see the GUI, right? I mean the empty GUI in this, right? So let us run it and see. Yes, so you can see now this is the empty GUI created. The empty GUI. So GUI right? So this is empty GUI created. Okay. Yes. So now what I'm going to do, I'm going to add more widgets. Right? So this is the empty window, and we are going to add widgets. We can do it simply. I'm going to add a canvas. I'm going to add canvas equal tk.canvas. So from Tkinter, I'm going to add the widget, so canvas widget, and first parameter should be like what's the window that this canvas should be placed, right? And we need to give the width and the height. So I'm going to give like 500 pixels width and 500 pixel height. So whether this is pixels or not, but anyway, for now let's consider it as pixels. Okay, then the background color, I'm going to give the background color. All right, so this is how we are going to create a canvas in Tkinter. Now make sure that this is like passed by keyword argument, right? The background color is given, but keep that in mind. We have to give some other parameters as well, but we are only giving the necessary parameters. Other values will be assigned to its defaults, right? Then the next thing is that we have to place it. We have to give the place where this canvas should be placed in the main window. So we can do it using the object that we created. So this is the object that we created, the canvas object. So we are going to place it using the grid. So we have actually main 3 methods of placing widgets in Tkinter windows, right? Grid, place, and the other type is grid, place, and yes, the other type is pack, right? So please go through these things. These are in the PDF I provided in the GitHub link, so you can go there and see. So we have like 3 methods of placing object, but I'm using the grid. So in the grid, what you have to give is the in the grid you have to give the row number and the column number. So I'm going to give like, okay, row is 0, column is also 0, row 0, column 0. So we need to run this now. I'm going to run it here. So let us see the output. So you are going to see this kind of a canvas, right? So you are going to see this kind of a canvas. We had 1 digits. So let me add some other widgets as well. Like let's assume that we need to add button, right? So we had like 4 buttons, as you can remember, 4 or 5. So I will add the save button, button.save, right? Save button. So these are like customized name I'm going to use, tk.button, right? tk.button, and we need to say where this is going to place, same as the earlier case in the window, and we have to give the text of the button. I'm going to put it like save, and the background color should be given, so I'm going to give green. So you can see in the PDF I'm going to provide, you can see the colors that we can use in this Tkinter graphical user interfaces. So you have like no need to give the hexadecimal code, you can type it by the name, green, light green, whatever. So that list is given in the PDF in the GitHub repository, right? And the foreground color is the color of the text. So I'm going to use white color there, and then we have to give a font, right? A font. So the font I'm going to use here will be like we can use any kind of a font, but I will give it like the Helvetica 20 bold. So this is important. Now you can give the font name and the size and the bold, italic, underline respectively, right? So simply you can do it like that. Then another important thing that as I mentioned previously, now yeah, this is only the button created. I will explain the command function later. There's a function called command. I will explain that later. So this is the first button, so we need to place it, right? Then we need to place it. So I'm going to place it using button dot grid, and I'm going to use like you can see now it should be row 1 and column 0. Column 0. So let me run this and see whether it's now you can see save button is. Now let me add quickly the other buttons as well, right? The other buttons as well. Button predict, the predict button, button predict, yes, and also here as well, and the row number 2, and this will be predict. The text will be predict, and I'm going to save the color, the background color to green as well in this case, right? So it will be blue as well, and the font will be the same. Right now you will see a issue here when we are going to run this. The same row, I forgot the same row, and the column should be changed, right? And you are going to see now this is the issue. So what happens now, we place the canvas as the row 0, column 0. So that size will be taken as the size of the column, right? So no matter what your column size, now the largest column size will be taken as the column size. So whatever the items we are going to place in the column 0 will have this kind of a space, right? So in order to get rid of this, what we can use, we can say that okay, after this column there are like the column span can be mentioned. So this means now after this column keep the space for like 4 objects after this column. That means okay, this column number 1 we can place in the second row, we can place 4 objects under this column. So that's what the column span means. So now we are going to add the other buttons as well here quickly. So the clear button, right, the clear button, and the I will show it here, change it here as well, and this should be also here, and the column will be number 2. Let me change the color here as well to red or yellow, and then the last button will be the exit button. The exit button which exit from the graphical user interface. So you can change the name and also the color. I will use red for this one. That's it, I think. So if we yes, okay, can now nothing going to happen. We didn't define the functionality of this, but what we did was like we created the graphical user interface and main window, and we added some widgets. So final widget, I'm going to add the label widget, right? So that will be added like this quickly. Label status, let's say. So I'm going to add a label widget, tk.label, and we need to mention the text and the firstly the window where the label is placed, and then the text I'm going to put like predicted digit equals none, right? And also the background color and the font, background color and the font. So let me use the background color as white, and the font will be a different font I'm going to use compared to the buttons, right? So the font will be same, but I'm going to like increase the size of the font a bit. Now let us see. I think this should be okay. Another thing, I didn't place it, right? So let me place it first. We have to give the column span here as well, right? So we say okay, 4 columns right? Let me run this again and see, right? So you can see it like this. Perfect. Now what we have to do, okay, so we have the graphical user interface with the buttons and the labels. Now we need to write the functionality for this, right? Write the functionality for this. Okay, so what we are going to do, then yeah, so the functionality is basically we had like, now first in this canvas nothing will be drawn up to now, so we have write the functionality to draw using the mouse, right? Okay, so in order to do that we can use a bind function, right? A bind function, canvas dot bind, right? Canvas dot bind. So then we have to give the bind function. I'm going to use it like b1 motion, right? b1 motion, and then we have to give the function event function. Now what's going to happen here, we are going to bind the canvas with this bind function. That means inside the function, if we drag the button 1 motion, that means if we drag the button 1 inside the canvas, right, this is going to create, this is going to call this event function, right? So you can refer this about this you can refer about this canvas bind functions. We have some other canvas bind functions as well in Tkinter, right? I think yeah, so we have, you can see the bind function, so please read these things and get the understanding. I'm just not going to explain about bind functions, but what we are going to do here, you can see button motion, right? The mouse is moved with the mouse button being held to specific left, middle or right mouse button use. So you can do it for button 1, button 2. Button 2 is the scroll button, button 3 is the right button, right? So what's going to happen when we are going to like when you are going to, yeah, so when you are going to move the button inside the canvas, pressed and moved, this function will be called, which function? This event function will be called, right? This event function will be called. Okay, so now let me define this event function. Right, let me define this event function like this. So this event is a customized function, def event function, right? Okay, then we need to get a parameter here as well. I will explain that later. Okay, right, I'll print like here, right? So in order to test it. Okay, let me run this one. So now what's going to happen when I'm going to write, so drag the mouse button here, so it's going to call to the event function and it will be printed like this. You can see, right? So that means whenever we are going to do this event button 1 motion inside the canvas, right, this is going to be called. Now we have like other as well, focus in, so you can check this as well. So let me check another one, double button, b1 double, b1 double button, yes, double button. Let's see, not sure whether it's going to work. I think it should be like b1 double. Let me, yes, double button like this, be given like this. Okay, So now what's going to happen when we are going to double click inside this right, so it's going to call the function. That's why it's print here, right? So you can see, okay, that's how it's going to work, right? Okay, now what we need actually is a button motion, v1 motion, right? So we will use it, right? Okay, now what we need to do, we need to draw whatever the we need to draw whatever thing according to the button motion, right? So we have to place it inside this event function. Okay, so in order to do that, we need another function to be used here, the pillow library. Yes, so here we can get the x point of the mouse at the function call, right? So I'm going to take it to the parameter called x, and similarly we can take y, okay? Y. Okay, so x and y parameters are taken. Then I'm going to create an oval, right? I'm going to create an oval like this. x1 equals x minus 30, y1 equals y minus 30, and also similarly I'm going to define x2 and y2. Then what we have to do, I'm going to create an oval, canvas dot create oval, canvas dot create oval, x1, we have to give some parameters, x1, y1, x2, y2, right? And then we have to give the color, fill black, fill black. Okay, so now what's going to happen, there is a issue with the code. Let me check first. Yeah, these should be like x2, y2. It's working, right? Now what's going to happen here, right? So now what's going to happen, basically we are going to take the mouse pointer, and we are going to like create an oval by like we are going to get a 30 plus 30 and minus 30, and we are going to create an oval from the mouse pointer. I will explain, I will show you that quickly what's going to happen. Yes, so we are going to take the mouse pointer first, right? The mouse pointer, and let's say this is the mouse pointer, and then we are going to define, right? Oh, okay, so let's say, okay, so these are the x and y, right? And so this is the mouse pointer, and this is x and y. Let's say I'm going to like x plus 30, x minus 30, right? Similarly y minus 30, y plus 30, and I'm going to take these parameters and create an oval, right? So this kind of thing will be created, and when I'm going to move the mouse, right, so these kind of things will be created. So that's how we are going to create the digit. Okay, okay, so yeah, so that's actually we create the canvas. But thing is, we can't get this canvas object into an numpy array. We need like an image. So image is an numpy array, you know. We can't get this canvas into an numpy array. So what we are going to do actually, now this is what the user is going to see, right? So this is what user is going to see. Parallelly, what we are going to do, we are going to create another object which we can like take into a numpy array, a similar object which we have to take into a numpy array. So this is what the user sees, the canvas, but similarly we are going to draw this parallelly in another object as well, in a numpy object. We are not going to take the canvas, but that object will be taken into to be passed to the convolutional neural network. So in order to do that, you need to get the pillow library. So you have to like import. You have to install it using pip install pillow, right? So please install this library in Anaconda prompt, and then you can get this pillow library pill import image pk image draw. So these functions will be taken from the pillow library. Now yes, okay, then what I'm going to do, I'm going to create some pillow objects here. I'm going to create an image from that pillow library, the object created. Now can you see we got the object, so we got a function called image. So I'm going to call it now image new. We need the RGB image, and we have to mention the size similar to the canvas size, and the color will be black. Now why? Now the canvas is like the background is white, the foreground is black, but our images should be foreground black and the background black and the foreground white. Why? Now can you see the images that we use to train the neural network? They are like this, right? Black background, white foreground. So we need to have the testing data similar to this. Now what's the purpose of this? Now this data should be downloaded from the internet. So the majority of the pixels of these digits are white. I mean, if the original case, right? In our case, in usual case we are going to like have the white background and the black foreground, but it takes lots of space. Now since 255 is the value for white, so we are going to invert the image. So in that case, the data sets are like this, the black background, since most of the pixels are background pixels, right? We are going to make them 0. That means we are going to save lots of space, right? Okay, so that's how the training data was there. So we have to use similar training data. We have to use testing data similarly, right? Okay, so that's what we are going to like have black background, and we are going to draw it using white color. The foreground will be white. Then I'm going to create a drawing object, right? Drawing object image draw dot draw, and I'm going to pass this object here. Now this is the original image, and this is the object that we are going to use to draw the image. Now what we are going to do, parallel to this, at the same time, when the canvas when we are going to draw it in the canvas, similarly we are going to draw the same thing in this image draw, and we are going to use the ellipse, since pillow not support ovals, it supports ellipse. So the similar parameters should be given, but now we need to like fill it using which color? We need to fill it using white, since our background is black and the foreground is white. Okay, right? So now what happens when we are going to draw in the canvas at the same time, in the image draw it will be drawn, similar image will be drawn. Now this is what we are going to pass to the neural network. Okay, let me import the NumPy library as well. Okay, now what we need to do, so in our canvas now perfectly these things are drawn, right? Now we need like use the functionality and define the functionalities. Now save button is going to save the whatever the digits that we are going to draw, and the predict button is going to do the prediction, and clear button should clear everything, and exit button should exit. How we can do that? We can give the parameters like this. Command. Now this is where when the button is pressed, the function will be called here. Whatever the function that we are going to mention here will be called. So I'm going to give a function called save. So what's going to happen whenever the button save is called, so button save is pressed, this save function will be called. So command keyword, we have to give the function name that should be called when the button is pressed, the particular button is pressed. So we have to define this function. So I will define that quickly. Def save, right? So this is to save the button, right? Okay, so what we are going to do, I'm going to define the save function quickly here. So similar, I'm going to define a count first. Let me define a count here. Zero, and I'm going to use that inside the function. So we are going to use the global variable count outside the function count, and I'm going to, like, now when the save button is pressed, I'm going to take the image there in the image object that we created using pillow. So I'm going to convert it to a numpy array. That image will be taken here, and that will be taken to, let's say, image array. So what's going to happen now, whenever we are going to press the save button, right, at that moment the whatever the thing we have drawn in the canvas will be taken into a numpy array, and we are going to resize it to we can use the resize function in OpenCV, right? I'm going to resize it to, let's say, our size is, so image array will be converted into our size, the interested size is 28 by 28. You can remember, right? So we use 28 by 28 images to save. So I'm going to, like, save cv2.imwrite str count. So I'm going to convert the count into a string and plus add the extension jpg, and I'm going to then increment the count, right? So what's going to happen now, when you are going to press save, the image will be saved and the count will be incremented by 1. Then at the next instant, when we are going to press the save, it will be saved as 2.jpg. First it will be saved as 0.jpg, then it will be saved as 1.jpg, right? So you can use this canvas to, like, create a data set as well, right? So if you need, like, single characters, you can draw it and use the save function and create a data set here as well, right? Try it. And then the function for, I will implement the predict function at the end. Now let me implement the clear function. So when the clear button is called, we need to clear everything in the canvas and that image object, both, right? So we are going to draw it in the canvas object and the image object. We have to clear the both when the clear button is called. So I'm going to define that function def clear, right? So def clear. Now the clear function will be called. Okay, so in clear function, what we have to do, we have to take the image and image draw objects, right? These two objects we created, we need to take, right? So we need to take those into the clear function, and also I'm going to delete the canvas, whatever the things they are in the canvas. Okay. I'm going to delete all of them, and we are going to initialize. These objects again. So those objects will be reinitialized and everything will be destroyed, right? So that's what's going to happen, right? Note that we need to like clear the canvas and the image. So we are using like the canvas is what we see, but image is what we are going to apply to the neural network. Okay, so then the exit button is quite simple. We can give it using a one command. We can destroy the window, right? And destroy the window, win.destroy. We can use the command win.destroy. Win.destroy. The window, the Tkinter window will be closed. No need to define a separate function. Then the most important thing, the predict function. So I'm going to like create a function called predict. Okay. So what we are going to do here, we need to have another function def predict, right? So this is where we are going to take the image and apply it to a neural network, right? Okay, so let me follow the steps. I want to like highlight some point here that we are going to pass the image to a neural network, but keep this in mind. The image should be in the same format as the training images. අර neural network එකට දාපු training images විදිහටම මේවත් තියෙන්න ඕනේ. අර 255න් බෙදෙන එක, resize කරන හැමදේම අපි මෙතන කරනවා, right? So we have like 500 image. So what we are going to do, first we are going to take it to a numpy array. Similar in the save function. First I'm going to take it to a numpy array. And then we need to convert the color. So the images were like in the gray color, not RGB. So our object is a RGB object. So it has 3 components, right? So first we need to convert it to gray. So I'm going to convert it to gray using this image array equals cv2.convert color, right? Convert color, and I'm going to apply the image array, and cv2.color BGR to gray, color BGR to gray. Then I'm going to resize it. So you can remember now this is like in 500 size. So we need to like convert it to 28 by 28 since our neural network is trained in 28 by 28 image. So whatever things that we did for the training images, that same format should be followed in the testing as well. So we need to resize it. Resize. So image array will be resized into 28 by 28 size, right? Okay, so that's it. And then can you remember we divided the images by 255 in order to convert it to a array in between all the values in between 0 and 1. So the same thing should be done here as well. And the image array finally should be reshaped like this before applying to the neural network. I will explain this on this Tuesday, why this reshape is required. For now, that keep this in mind, we need like reshape it by not 28 by 28, 1 comma 28 by 20. Then what we can do, we are going to apply it to the model dot predict, right? And we are going to apply the image. So neural network, I'm going to apply it to the neural network and get the prediction. Now what we need to do, we need to get this neural network, right? So how to get this neural network? We have the H5 file. So what we are going to do, I'm going to get the neural network architecture. We have several methods of loading a neural network. So this is one of the methods that we can use to train load the trained neural network to our code, right? First we need to get this architecture, and we have several methods. I will explain that later, but I will now create a function called load model, or else we can write at the code, we can have it like this as well. Then we need to use the function called load model. So whatever the name, we have to give it here. Whatever the name. So now we are not going to train the neural network here. We are going to like have the neural network, the same neural network architecture is defined here. as we use for the, I mean, you can't change the neural network architecture since we are going to use the same neural network here. We are going to load the same neural network weight, so the neural network architecture should be the same, but we are not going to train it again, right? So we are using the trained model. So what you can do without training, we can straight away we can directly load the weight file. So now what will happen? The knowledge will be loaded here, right? So this is a similar to a trained neural network. We are going to load the weights here. Now this is a trained neural network, right? Now we can get predictions from this, right? Now you know that this is going to give us 10 probabilities, right? So you need to keep this thing in mind. We are going to get 10 probabilities since we have a softmax layer at the end. So what we need to get? We need to get the label. I hope that you can remember the argmax function, right? Argmax function. So we can get the label from this one using this command, right? Then what we need to do, this label should be shown, right? This label should be shown, right? Sorry, this should be not load model, this should be load weights. So now we need, like, when this is drawn and when the predict is predicted, now we need to update that value here, so whatever the value is given by the neural network. Okay, so in order to do that, what we can do, we can update the label status, right? So label status dot config text equal predicted, right, digit, and we need to give the label, whatever the predicted label here, right? So it will be updated, the label will be updated. Now I think that's pretty much everything. So let's run this and see whether we are going to get the correct results. CV2.not defined. Yes, we haven't coded the CV. Now let us run this and see again. Convert color is wrong. This should be it, like this. Yes, it should be seen. It's working, right? Now clear button is also working. You can set the save button. Save button, in another issue button. Save function. We have to give what we are going to save. So image array will be saved. Now probably it will work. Right, so let me predict this. Now the thing is, now can you see when you are going to press the clear button, this is not changing, right? So what we can do, we can in the clear button also we have to give it like this, predicted digit, like this. Now it will be updated, right? I'm not sure that this is working for everything. Let's see. So I mean, the things that I mentioned, the issues with feed-forward neural networks when it's dealing with images, that issues are there, right? So please check it and try to implement. Okay, so we will discuss about these things, try to implement this, and we will discuss if you have any issues on Tuesday. And Tuesday we are going to move to the CNN implementation, right? So thank you very much, and drop me messages if you have any issues in this code. Thank you very much.